Okay, we're looking at another small part of trigonometry, and they're called exact values. So these are the ones that apply to some certain special numbers to do with the angles, 30, 45 and 60 degrees, or their equivalent in radians. So just on your calculator, if you just punch up sine 30 on your calculator in degree mode, just verify that you do get 0.5, and 0.5 is the same as a half. Okay, so you should have done that. And if we draw a right angle triangle, okay, so sine is the opposite and over the hypotenuse. So on a triangle, okay, I put 1 on the opposite and I put 2 on the hypotenuse. So using Pythagoras, if I just call that x, I've got x squared. So 2 is the biggest side, so I've got to subtract. So I've got 2 squared minus 1 squared. 4 minus 1 equals 3. And so x equals the square root of 3. Okay? So that's just using Pythagoras. So if I've got sine 30 is a half, okay, so that's an exact fraction. When I do cos 30, rather than putting it on the calculator and getting a messy decimal, which you could, it's 0.866, something like that. If I do adjacent, which is root 3 over hypotenuse, 2. So that would be the same. So on your calculator, if you do cos 30 on your calculator, you'll get 0.866, but root 3 on 2 is the same. But we call this an exact value. Okay, so anytime you have surds, you get exact values, otherwise you get decimals. Okay, and then you do tan 30. On your calculator, you get a decimal 0.577, I think. I'm just doing this without a calculator. But on your diagram, you've got the opposite over the adjacent, and so that's the exact value. So rather than getting a decimal, you get an exact value. Now, while we've got this same triangle, before we lose it, if that's 30 degrees there, then that must be 60 degrees up there, because the other side of the other angle down here is 90. So if one angle's 30, the other one must be 60. And so using the same triangle, you can get sine 60, cos 60 and tan 60 just by changing your position of your opposite and adjacent. So let's try that color. Okay, so 60's up here and opposite is down here at root 3, and hypotenuse is still 2. Okay, cos 60 is the adjacent over hypotenuse, and tan 60 is opposite over adjacent, which is just root 3. Okay, so there's 2 more. Now we're going to have it looks really complicated, but I'm going to give you a summary table when we finish. So at the moment, just copy those down, but the first triangle just comes because that sine 30 equals a half. That's all we had to draw. So if you ever forget these exact values, you just have to draw a triangle and do your Pythagoras calculation to get the root 3. Okay, so let's have a look at the next triangle, which gives us nice numbers. Okay, so on your calculator, just verify that tan 45 equals 1, and when you're ready, come back to the video. Okay, so you've verified that tan 45 equals 1. So there's a triangle with 45 in the corner, and so that's the opposite, and that's the adjacent. Tan is opposite over adjacent, so you got 1 over 1. And then using Pythagoras, you end up that this is going to be root 2. Okay, if you call this x, we'll do it the long way. So we've got x squared equals 1 squared plus 1 squared equals 1 plus 1 equals 2. And so x equals root 2. Okay, so that means we can now do sine 45, cos 45, and tan 45. So tan 45 was the one we did, because that was up there. And then sine 45 is the opposite over the hypotenuse, and cos is the adjacent over the hypotenuse. So they're the same numbers. Okay, so let's have a look at what it looks like in a summary table. Okay, so this is what it looks like as a summary. So 30 degrees is the same as pi on 6. We did the radian video earlier. 45 is pi on 4, and 60 is pi on 3. So you just have to know those ones, because you could be questions asked in degrees or radians. So if you have a look, all I've done is I've just put all the information that we've just been having on the last 2 pages. So sine starts at a half, goes to 1 on root 2, goes to root 3 on 2. But once you've written down that first line, the second line is the direct opposite order. So just move first, second and third, and becomes, just change the order. So the third becomes the first, second stays the same, and the third moves over here to the first. Okay, so once you know the first line, the second line is automatic. And then to get the third line is just tan is sine over cos. We did that on an earlier video. So tan is sine over cos. So the 2's cancel out, so just left with 1 over root 3. The root 2's cancel out, and 1 over 1 is 1. The 2's cancel out, and you're left with root 3 on 1, which is just root 3. So once you've got the first line, you get the second line, and the third line is just division. Otherwise, just rote learn it like we used to have to do when we were kids. Okay, so that's the summary table, and we'll look at some examples on the next page when you're ready. Okay, so here's another summary. Just remember that we've got our all stations to central, first quadrant, second quadrant, third quadrant, fourth quadrant. And the other thing you have to remember from previous is theta, 180 minus or pi minus, 180 plus or pi plus, 360 minus or 2 pi. Oh, it's here, 2 pi minus. So there's no mistakes here. I thought I made a mistake, but I didn't. So theta, 180 minus, 180 plus, 360 minus, or theta, pi minus, pi plus, 2 pi minus. So you have to know that all the time. All right. So let's have a look at an example. Now, there's going to be more than one answer, and I didn't define, so I'll just make it easy. I'll just do in degree mode, okay? Because it could be 0 to 2 pi, but for this one, and it's our last one, we'll just do it in degrees. So the steps are still the same. This is a positive number, so sine is positive in first and second quadrant. Okay, and then you say, that 1 on root 2, that looks familiar. So you look up the chart, or you know your chart. So in the first quadrant, theta is going to be, and we're in degrees, so it's going to be 45 degrees. And in the second quadrant, it's going to be 180 minus 45, which is 135 degrees. So again, with these ones here, you can know you're right, because that equals a decimal. 1 over root 2 equals a decimal, and you could check that the sine 45 and the sine 135 is the same decimal. Okay, so in the next one, so we've got a negative cos. So cos is negative in second and third quadrant. Okay, so what we do is we pretend we've got a positive answer. So in the first quadrant, okay, so we've got negative, so we pretend it's positive. And again, if you need to, got back here, so we're looking at this value here. So cos is root 3 on 2, so we're looking at 30 degrees again. So in the first quadrant, it's 30 degrees, okay? And then we just do second quadrant. So that's not the right answer, but in the second quadrant, theta will be 180 minus 30 is 150. And in the third quadrant, theta equals 180 plus 30 is 210. Okay, so we might, I didn't have planned for a page 6, but we'll do a page 6 with a in radian measure. So tan theta equals -1, theta is 0 to 2 pi. Okay, so we'll do one in radian measure, so you've got one for your notes. Okay, so first thing you do is tan is negative. All stations to central, so we're negative in the second and fourth quadrant. We pretend that in the first quadrant we have a positive answer. Now we're in radian mode, so if we pretend it's a positive one, so we get pi on 4, the 45 degree one. So in the second quadrant, theta equals pi minus pi on 4. So you have a whole pi minus a quarter of a pi equals 3/4 of a pi. And in the fourth quadrant, theta equals 2 pi minus pi on 4. So if you have two of them and you subtract one of them, you have 1 3/4, which is 7 pi on 4. Okay, so there's some example, and there's a worksheet on 4 quadrants and exact values on Moodle. Thanks for that.